Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video is the second of two parts of the series Trigonometric Identities. It is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. It is recommended to view the video Trigonometric Identities Part 1 before watching this video. In this video, we will be discussing the sum and difference formulas, squared identities, double angle formulas, half angle formulas, and product to sum and sum to product formulas. We can derive the sum and difference formulas by first observing the unit circle. We then establish an angle alpha with a point P sub 1 where angle alpha meets the perimeter of the unit circle. We then make a smaller angle beta with alpha minus beta as the difference and establish the point P sub 2. The coordinates of P sub 1 and P sub 2 can be expressed as xy on the coordinate plane. However, if we observe that cosine beta equals x over the hypotenuse, and on the unit circle the hypotenuse equals 1, then x is equal to cosine beta. Similarly, y will be equal to sine beta. We can also use the same to express the coordinates of P sub 1 as cosine alpha, sine alpha. Next, let's establish a new unit circle, this one with just one angle, alpha minus beta, where P sub 3 will be at cosine alpha minus beta, sine alpha minus beta, and P sub 4 will be at 1, 0. Given these two unit circles, the triangle based on the origin P sub 1, P sub 2 will be congruent with the triangle on the second unit circle at the origin P sub 3 and P sub 4. This means that the distance from P sub 1 to P sub 2 will be equal to the distance from P sub 3 to P sub 4. Next, we apply the distance formulas to the two pairs of points. The distance from P sub 1 to P sub 2 as a square root of cosine alpha minus cosine beta quantity squared plus sine alpha minus sine beta quantity squared. And the distance from P sub 3 to P sub 4 is the square root of cosine alpha minus beta minus 1 quantity squared plus sine alpha minus beta minus 0 quantity squared. Since we established these triangles as congruent, these two distances will be equal. We can now square both sides to remove the root symbol. Next, we FOIL the binomials. Cosine alpha minus cosine beta quantity squared equals cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta. Sine alpha minus sine beta quantity squared equals sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. Cosine alpha minus beta minus 1 quantity squared equals cosine squared alpha minus beta minus 2 cosine alpha minus beta plus 1. Finally, sine alpha minus beta minus 0 quantity squared equals sine squared alpha minus beta. On the left side of the equal sign, we compare cosine squared alpha plus sine squared alpha and cosine squared beta plus sine squared beta. Each of these equal 1 and added together equals 2. On the right side of the equal sign, cosine squared alpha minus beta plus sine squared alpha minus beta equals 1, plus the existing 1 is 2. Next, subtract the 2 from both sides, leaving negative 2 cosine alpha cosine beta minus 2 sine alpha sine beta equals negative 2 cosine alpha minus beta. Divide all terms by negative 2 to get our final identity, cosine alpha cosine beta plus sine alpha sine beta equals cosine alpha minus beta. The following sum and difference formulas are derived the same way as we just did with cosine alpha minus beta. Cosine alpha plus beta equals cosine alpha times cosine beta minus sine alpha times sine beta. Sine alpha plus beta equals sine alpha times cosine beta plus cosine alpha times sine beta. Sine alpha minus beta equals sine alpha times cosine beta minus cosine alpha times sine beta. Tangent alpha plus beta equals tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. Tangent alpha minus beta equals tangent alpha minus tangent beta over 1 plus tangent alpha times tangent beta. These formulas can be used to find the exact value of a cosine, sine, or tangent function where the exact answer is not easily determined, but the angle can be expressed as a sum or difference of two angles whose exact solutions are known. Find the exact values of the following trigonometric expressions. Cosine 165 degrees. 165 degrees is not expressed directly on the unit circle, but can be expressed as 120 degrees plus 45 degrees, both of which are. Using the previously established identity, cosine of 120 degrees plus 45 degrees equals cosine 120 degrees times cosine 45 degrees minus sine 120 degrees times sine 45 degrees. Referencing the unit circle, we see that cosine of 120 degrees equals minus 1/2, cosine of 45 degrees equals the square root of 2 over 2, sine of 120 degrees equals the square root of 3 over 2, and sine of 45 degrees equals the square root of 2 over 2. Take the fraction multiplications to get negative square root of 2 over 4 minus square root of 6 over 4. Simplify to get negative square root of 2 plus the square root of 6 over 4. Next, let's find an exact answer to tangent 19 pi over 12. First, 19 pi over 12 can be expressed as 3 pi over 12 plus 16 pi over 12. Simplify them both to get tangent pi over 4 plus 4 pi over 3. Here we use the known identity to get tangent pi over 4 plus tangent 4 pi over 3 all over 1 minus tangent pi over 4 times tangent 4 pi over 3. We then consult the unit circle to fill in the values. Tangent pi over 4 equals 1. Tangent 4 pi over 3 equals the square root of 3. Simplify to get 1 plus the square root of 3 over 1 minus the square root of 3. Next, use the conjugate to rationalize the denominator. When we complete the binomial multiplication, we get 1 plus 2 square root of 3 plus 3 over 1 minus 3. Simplify to get 4 plus 2 square root of 3 over negative 2. Simplify again to get the final answer, negative 2 minus the square root of 3. To arrive at our square identities, we start with the sum formula, cosine alpha plus beta is equal to cosine alpha times cosine beta minus sine alpha times sine beta. Let's assume that alpha and beta are the same angle called theta. This means that cosine theta plus theta equals cosine theta times cosine theta minus sine theta times sine theta. Simplify to get cosine 2 theta equals cosine squared theta minus sine squared theta. If we add, then subtract sine squared theta on the right side, we can simplify to get 1 minus 2 sine squared theta. Subtract the 1 and switch the signs to get 2 sine squared theta equals 1 minus cosine 2 theta. Then divide by 2 to arrive at the identity sine squared theta equals 1 minus cosine 2 theta over 2. We can do similar manipulations to arrive at the other squared identities. Cosine squared theta equals 1 plus cosine 2 theta over 2. Since tangent squared theta equals sine squared theta over cosine squared theta, we can derive that tangent squared theta also equals 1 minus cosine 2 theta over 1 plus cosine 2 theta. Starting with the sum formula, sine alpha plus beta equals sine alpha times cosine beta plus cosine alpha times sine beta, and assuming alpha and beta are equal, we can arrive at the double angle formula, sine 2 theta equals 2 sine theta cosine theta. Using the sum formula, cosine alpha plus beta equals cosine alpha times cosine beta minus sine alpha times sine beta, and again setting the two angles alpha and beta equal to theta, we arrive at the double angle formula, cosine 2 theta equals cosine squared theta minus sine squared theta. Next, we can take this identity and add and subtract sine squared theta, so that cosine squared theta plus sine squared theta equals 1, to arrive at the next identity, cosine 2 theta equals 1 minus 2 sine squared theta. If instead we add and subtract cosine squared theta, and again combine sine squared theta plus cosine squared theta to equal 1, we arrive at the identity cosine 2 theta equals 2 cosine squared theta minus 1. Using the sum formula for tangent and assuming alpha and beta are both equal to theta, we can arrive at tangent 2 theta equals tangent theta plus tangent theta over 1 minus tangent theta times tangent theta, or 2 tangent theta over 1 minus tangent squared theta. As an example, let's use the double angle formulas to arrive at the exact value of sine 2 theta and cosine 2 theta, given sine theta equals 3 over 5, for theta between 0 and pi. For this, we construct a right triangle, designating one of the non-right angles as theta. Since sine theta equals 3 over 5, then the opposite side must be 3 and the hypotenuse 5. Using the Pythagorean theorem, we can solve for the third side, b. 3 squared plus b squared equals 5 squared, 9 plus b squared equals 25, b squared equals 16, and so b equals 4. We can now see that if sine theta equals 3 over 5, and the adjacent side equals 4, then cosine theta must equal 4 over 5. Given the identity, we fill in the values to get sine 2 theta equals 2 times 3 over 5 times 4 over 5, or 24 over 5. For cosine 2 theta, we fill in the values, take the squares to get 16 over 25 minus 9 over 25, or our final answer, 7 over 25. To derive the half-angle formulas, we start with the squared formulas previously established. Let theta equal alpha over 2. Substitute, then square root both sides to get sine alpha over 2 equals plus or minus the square root of 1 minus cosine alpha over 2. The same substitution can be used to arrive at cosine alpha over 2, which equals plus or minus the square root of 1 plus cosine alpha over 2. We do the same substitution to arrive at tangent alpha over 2 equals plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. Note that in each case, the quadrant of alpha over 2 will determine whether the solution is negative or positive. For example, let's find the exact values of sine theta over 2 and cosine theta over 2, given sine theta equals 3 over 5, for theta between 0 and pi. Again, using the right triangle, we have already arrived at the solution cosine theta equals 4 over 5. Starting with the half-angle formula, for theta over 2, the first quadrant is positive. Therefore, sine theta over 2 equals the square root of 1 minus 4 over 5 all over 2. Simplify to get the square root of 1 over 5 over 2. 1 over 5 over 2 simplifies to 1 over 10. We rationalize the denominator to get a final answer, the square root of 10 over 10. Next, we use the half angle for cosine, and again we use positive for cosine in quadrant 1. Fill in the values to get the square root of 1 plus 4 over 5 all over 2. Complete the fraction addition to get 9 over 5 over 2, which can simplify to 9 over 10. The square root of 9 is 3. Rationalize the denominator to get the final answer, 3 times the square root of 10 over 10. For another example, let's find the exact answer for the expression tangent 7 pi over 8. Looking at the unit circle, 7 pi over 8 does not have an exact answer depicted, but tangent 7 pi over 4 does, noting that cosine of 7 pi over 4 equals the square root of 2 over 2. With this, we can use the half-angle formula for tangent. Let alpha over 2 equal 7 pi over 8, which makes alpha equal to 7 pi over 4. 7 pi over 8 is in quadrant 2, which is negative for tangent. Then we fill in our values. Tangent 7 pi over 8 equals negative the square root of 1 minus cosine 7 pi over 4 all over 1 plus cosine 7 pi over 4. We have already established that cosine 7 pi over 4 equals the square root of 2 over 2. Inside the radical, we use the common denominator of 2 to arrive at 2 minus the square root of 2 over 2, all over 2 plus the square root of 2 over 2. The compound denominators cancel, leaving us with negative square root of 2 minus the square root of 2 over 2 plus the square root of 2. We use the conjugate to rationalize the denominator to get negative square root of 2 minus the square root of 2 quantity squared over 4 minus 2. Take the square root to get negative 2 minus the square root of 2 over the square root of 2. We again rationalize the denominator to get negative 2 times the square root of 2 minus 2 over 2. Cancel the common 2 and distribute the negative to get the final answer 1 minus the square root of 2. To derive the product to sum formulas, we start with the sum and difference formulas. First, cosine alpha minus beta and cosine alpha plus beta. Adding these two equations results in cosine alpha minus beta plus cosine alpha plus beta equals 2 cosine alpha cosine beta. Divide both sides by 2 to get cosine alpha times cosine beta equals 1/2 cosine alpha minus beta plus cosine alpha plus beta. If we take the same two sum equations and subtract them, we get cosine alpha minus beta minus cosine alpha plus beta equals 2 times sine alpha times sine beta. Divide both sides by 2 to get sine alpha times sine beta equals 1/2 cosine alpha minus beta minus cosine alpha plus beta. Finally, we add the formula sine alpha plus beta to sine alpha minus beta to get sine alpha minus beta plus sine alpha plus beta equals 2 times sine alpha times cosine beta. Divide both sides by 2 to get sine alpha times cosine beta equals 1/2 times sine alpha minus beta plus sine alpha plus beta. As an example, express the following product as a sum: sine 4 theta times sine 2 theta. Using the product to sum formula, let alpha equal 4 theta and beta equal 2 theta. So sine 4 theta times sine 2 theta equals 1/2 the quantity of cosine 4 theta minus 2 theta minus cosine 4 theta plus 2 theta. This simplifies to 1/2 the quantity of cosine 2 theta minus cosine 6 theta. To derive the sum to product formula, we start with the product to sum formula. Let alpha equal alpha plus beta over 2, and let beta equal alpha minus beta over 2. Substitute and multiply both sides by 2 to get 2 times sine alpha plus beta over 2 times cosine alpha minus beta over 2 equals 2 times 1/2 times sine alpha plus beta over 2 plus alpha minus beta over 2 plus sine alpha plus beta over 2 minus alpha minus beta over 2. 2 and 1/2 cancel. Solve the fractions inside the sine functions to get sine 2 alpha over 2 plus sine 2 beta over 2. The 2's cancel to get sine alpha plus sine beta. Our final identity is therefore sine alpha plus sine beta equals 2 times sine alpha plus beta over 2 times cosine alpha minus beta over 2. The same proof is used to arrive at sine alpha minus sine beta equals 2 times sine alpha minus beta over 2 times cosine alpha plus beta over 2. Cosine alpha plus cosine beta equals 2 times cosine alpha plus beta over 2 times cosine alpha minus beta over 2. And cosine alpha minus cosine beta equals 2 times sine alpha plus beta over 2 times sine alpha minus beta over 2. As an example, express the following sum as a product: cosine 2 theta plus cosine 4 theta. Starting with the appropriate sum to product formula, we fill in the values to get 2 times cosine quantity 2 theta plus 4 theta over 2 times cosine quantity 2 theta minus 4 theta over 2. This can be simplified to 2 cosine 3 theta times cosine negative theta. Since cosine is an even function, meaning cosine of negative x is equal to cosine of x, our answer can be expressed as 2 cosine 3 theta times cosine theta. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.